This is Nidhi, Vice Chairperson, IET Students Chapter BIT Sindri. I welcome you all back to our session. I'll be your host for the session. We are back again with the day 4 of the webinar series, with its fifth and the very last talk for the series. IET at BIT is a students chapter of the national technical body with its headquarters at New Delhi. Let me inform you about the format of the webinar. We will start with a brief discussion on the topic by a speaker for 30 minutes. Meanwhile, we request our viewers to post their questions through YouTube chat box. We will try our best to put them to our speaker within given time frame. Today's speaker is Ms. Mansi Priya, and she'll be speaking about the topic Introduction to Machine Learning. Now, I would like to welcome our speaker for this session, Ms. Mansi Priya. Hi, ma'am. It's a pleasure to have you here.
Hello, everyone. It's nice to be a speaker here, and I'm looking forward to it.
Ma'am, would you like to introduce yourself or shall we introduce you?
You can introduce me, and I'll be giving my introduction in the presentation itself.
Okay. Ms. Mansi Priya is an experienced data scientist with a demonstrated history of working in IT and service industry, an esteemed alumni of BIT Sindri in computer science and engineering branch. She has skills in data science, Python, Java, C++, data structures, and SQL. Mansi ma'am, please proceed with the session. Over to you, ma'am.
Yes, I'll present my screen. Just a moment. Yes, can you confirm me if my screen is visible?
Yes, ma'am.
Yes. Okay. So just let me know. Can I just simply start now?
Yes, ma'am, you can start.
Okay. So, hello and good afternoon, everyone. I am Mansi Priya. Today we will be discussing about very basics of machine learning. So, let me first start by introducing myself. I am a data scientist with 2 years of experience. Currently, I work at Yamaha Motor Advanced Technology and I'm currently in Japan. My core interests lie basically in the domain of machine learning and that in providing useful insights from data and inform business decisions. So that was a very brief introduction from my end, and without wasting much of your time, let us start. So, firstly, let me tell you what will be our agenda for today. So, firstly, we'll discuss what is machine learning, the different types of machine learning. Then, after that, we'll go into machine learning life cycle. When you get a problem, how to approach and how to solve it using machine learning. And after that, we will be the most important section, that is how to start if you're looking forward to go into machine learning field. So, that is all for today, and let us start. So, one fact that I would like to ask you, and I'll tell that this is a thing that we humans we learn from our past experiences. We know if we put our finger into the fire, how it can burn, or if we know if we touch a cactus, you know how it can prick your fingers. So these are all things, some things that we learn from our past experiences. And there is one more fact that we can teach machines to follow the instructions that are being given by us. So why not combine both of these factors and make a model? And that is, we can train the machines that they can learn from the past data, so just like us, they can learn from our experiences or their own experiences, and they can do things that we do in a much better and a faster manner. So actually that is machine learning. But it's not just simply that, it is also about understanding and reasoning. So, well, imagine a regular day in your life and try to look how technology and particularly machine learning is almost present everywhere. So, you would be using some voice control devices like Alexa, Siri, or Google Assistant. So, how do you think the device is able to recognize your voice and reply to you according to that? And for whatever instructions you are given, you give, that device is able to follow that. So, how does it do that? Well, actually, that is machine learning. You would also be using Facebook. So, you might have definitely come across that in the images, the people are tagged automatically in that. So, how do you think that is also done? How faces are being recognized by Facebook? Well, that is also because of machine learning. Then obviously you would have come across Netflix also, and in this lockdown people have started using Netflix a lot. So you would have come across that Netflix provides you recommendation that which show or which series you should watch next. So how does Netflix does that? That is also with the help of machine learning. You would have also used applications like Ola or Uber, and you would have seen that prices rise during rush hours. Or how do you think that Ola share works? These all things use machine learning. Well, these are very just few examples, and if you look around yourself, you can find that machine learning is almost omnipresent, and it is almost in everything and can be applied in everything that is present around you. So that is why it is very important to understand what is machine learning. So let us now try to define what is machine learning and try to give it a definition of what it is. So, according to a very small definition that I picked up, machine learning is the study of computer algorithms that improve automatically through experience, and it is known as a subset of artificial intelligence. So, when I talk about machine learning and artificial intelligence, I often come across people who are confused that what is the difference between AI and ML. So that is why I tried so that you could just understand it using a simple analogy here. Imagine this circle as artificial intelligence. So if a machine can play chess based upon the rules on how to move the different pieces on the board, just following those rules, if a machine can play, then that is known as artificial intelligence. Then this is the subset machine learning of artificial intelligence. That machine learning in this system, if a machine learns to play chess from analyzing past chess games that have been played by humans, then it is termed as machine learning. Well, coming across these terms, you would also have come across a term that is deep learning. So that is why deep learning is nothing but a subset again of machine learning. And in this system, when a machine learns to play chess by playing against themselves, then that is termed as deep learning. So I think this was pretty much easy and very much useful for you to understand the differences between AI, ML, and DL. Now, when we have understood what is machine learning, let us try to understand different types of machine learning. So, these are basically three types: supervised learning, unsupervised learning, and reinforcement learning. Let us try to understand them with simple examples. So, this is my friend Dave, and he received a gift. So, he's very confused. Why is he confused? I'll tell you that after receiving the gift. Is that he received 5 million coins of 1 rupee, 1 euro, and 1 yen. And it is very difficult for him to analyze and count everything by himself. So that is why he wants to make a machine who can count it by its own. But how will that machine be able to recognize which coin is that? So for a fact, our friend Dave, he knows that 1 rupee coin weighs 3 grams, 1 euro coin weighs 7 grams, and 1 yen coin weighs 1 gram. So that is what he used, and being a machine learning enthusiast, he has put and made a model out of it. So what he did was the weight of these coins, he made it as features. Features is a jargon term used in machine learning. So these are nothing but the input things that you need to put in your model that are termed as features. So he used weight as his features, and the output that the model should give, that is termed as label. So here the currency, whether it is a 1 rupee, 1 euro, or 1 yen, that was the label. So we're using the features, we can now tell what is the currency. So, for example, if you get a coin that is of weight 3 grams, that machine will be able to tell you that it is a 1 rupee coin. So, here we can see the input feature that we put in the model, that was the data that we had put inside it, that contained different output variables also, whether it is a 1 rupee, 1 euro, or 1 yen, which we termed as label. So, that is why here our input data actually had labels. So that is why this whole learning, this kind of learning where we have labels present, that is termed as supervised learning. So I think this was you were able to clarify on supervised learning, and it will be more clear if you go into unsupervised learning. So let us now try to understand what is unsupervised learning. So this is our friend Dave again, and he's much more like me. He doesn't have much idea of cricket players. So I don't know, and Dave, similar to me, Dave also doesn't know if a player is a batsman or a bowler. And similar to me, Dave also can't tell whether that person is a bowler or a cricket or a batsman. So what he does, he puts this data into a machine, and that machine helps him to find patterns. So it gives him a graph something like this. Here you can see there are two separate clusters that are being found. There are people who take more wickets but less runs, and there are some people who take more runs and less wickets. So these two form two separate groups. So you can obviously, using your common sense, you can say that the people who took more wickets and less runs, they are the bowlers, and while the people who took more runs and less wickets, that were the batsmen. So these are, in this scenario, you can see that I did not give, or Dave did not give, any labels here that this particular this particular runs, if a person goes more than this run, he is a batsman or he's a bowler. That was not being defined in the input. So here we have no labeled data. So that is why this is termed as unsupervised learning, in which you don't have a label present in your input data. The third kind of learning that we come across is reinforcement learning. It is a little bit different other than the supervised and unsupervised. Let us see how. So this is our machine. We give an image of an apple to this machine. So this machine it knows that he has to predict among the different fruits whether which fruit is this image. So the machine predicts that this is a mango, but we know that this is wrong. So what we do, we don't tell that this is an apple, we just give it a feedback that whatever was your output, that is wrong. So this cycle repeats many times. Sometimes it can give you a banana, sometimes it will give you a orange, and we keep on giving it feedback that it is wrong. Sometimes it may give apple also, then we give it a positive feedback. So using the positive and negative feedback, this machine is now able to understand that when an image of this something like this comes, this is an apple. So here what the important feature to be noticed was, it works on the feedback. So that is why it is known as reinforcement learning. So that was my explanation about the different types, you can say. So let me now check whether you were able to understand whatever I taught you, whatever I told you just now. So you can, I will ask you questions. You can put up your answers on the chat box section here. So let me first ask you this first question. This is, you have to tell whether this problem is a supervised or an unsupervised problem. So in the input, we have given different images of apples, bananas, and mangoes, and we have not given any labels to them, whether what is what, and we have put directly into the algorithm. And this algorithm automatically makes three separate groups, and these three separate groups have images. One group has images of apple, excuse me, one group has images of bananas, and one group has images of mangoes. So what do you think, whether this is a supervised learning or unsupervised learning? You can put the section on put your answer on the chat box section. Okay, so we have started getting answers for this question. Thank you so much for people who are replying. I can see that you were not sleeping. Okay, there is a bit of different. There are more people with unsupervised. There is one person with supervised. I'll give you more 10 to 15 seconds to reply. Yes, so as I can see, there were maximum number of answers that it was an unsupervised learning, and you are right. This is a case of unsupervised learning. Thank you so much, and everyone for participating. I'll ask one more question now. So let us take this scenario. Here we have images of cats and dogs, and these are labeled whether the image is of a cat or a dog. So when it is trained, after that it gives a output when give it an image. So when the we give an image of a cat, this is able to predict whether it is a cat or a dog. So what do you think? What is this? A supervised learning or an unsupervised learning? You can write your answers again in the chat box section. Yes, thank you so much everyone for participating. I can see the answers coming now. Yes, so I think we again got a very majority of answers as supervised learning, and you guys are correct. Here we have labeled photos, and someone tried to give an explanation also. Shailesh, that data is labeled. Yes, you're right. The data is labeled, so that is why this is a supervised problem. Thank you so much, everyone, for participating. Now, let us come into a little bit depth about supervised learning. Supervised learning is a learning that you will come across very much, and it is a very common type of learning. So that is why I'll try to just explain to you the two different types of supervised learning, that is classification and regression. So we all use Gmail application. So when we receive an email, that is automatically classified whether it is a spam or it is not spam. So how do you think? This also uses obviously machine learning. So here what where I would like to draw your attention is on the output. The output here actually is two classes, or you can say groups, that it is a spam or not spam, into which that machine learning classifies whether this email that you received is a spam or not spam. So here the output is 2, but it can be more than 2 also. But the thing that happens all in all classification problems is that we have a defined set of groups or classes. So that is why this is termed as classification. So now let us try to understand regression. Regression, our friend Dave is again, and due to this COVID, he was not able to get a job. So that is why he joined a real estate business with his father. So what he has to do, he has to sell houses, and he gets houses and he has to resell them. But he, being a machine learning enthusiast, not knowing anything about the real estate business, so what he does, he gets and collects the previous data that was present. He gives a data something like this. This data has a particular size, a number of bedrooms, year built, number of bathrooms present, and then after that has the price, on which price this particular house was being sold. So what he does, he collects this data and gives it into the system. So now the model is trained, and when you give a data something like this of a particular size, number of bedrooms, the year built, and number of bathrooms, then this machine is now able to give a price, that is $5,50,000, that on this price this house should be sold. So in this scenario, again, I will draw your attention to the output. The output you can see is a numerical value, a number. So that is here in the previous scenario in classification we saw that there were different classes, but in this scenario we have some numbers, and these can be any value that can be possible for that particular house. For example, in this is a house price prediction problem. So that is why here the price, the output can be any price. It could have been 6 lakh, it could have been 2 lakhs, or any price. So there are no well defined classes here. What we have is a quantity. So that is why this is termed as regression. So I hope these two categories were clear to you, and again I have this quiz for you so that I would be able to check whether you were able to understand the difference between regression and classification. So let us start. This is my first question. See, in this scenario, there is a model being made, and I input different images of strawberries. So this algorithm, this model is able to predict the price, predict the size, the length of that strawberry using that image. So here you can see that the height can be given as 2 centimeters, or whatever value that can be possible, that can be judged according to that. So what do you think? This is a classification problem or a regression problem? You can again write your answers in the chat box section. I can see your answers. Many of you have replied. Most of you are saying it as regression. There is someone who said it as classification too. Okay. As I can see, majority of you have given the answer as regression, and yes, you all are right. This is a regression problem because the output that we are trying to predict is a number, and it can be any number. The height can be anything. Here it is 2 centimeter, 5 centimeter, 7 centimeter, or it could have been 3.5 centimeter. So what we are trying to predict is not something of classes, but rather than a quantity. So that is why this is a regression problem. Okay, now comes the second question. Here we are giving images of cats and dogs, and in this model is able to predict whether it is a cat or a dog. So what do you think? This is a classification problem or a regression problem? And as before, you can put the answers in the chat box section. Sumit is asking what about prediction we are what about after prediction we are classifying. We are not classifying those strawberries. We are simply giving the height of the strawberries. So that is why it is a class regression problem. Yes, here I can see a very unanimous answer that it is a classification problem. Yes, so all of you are right, and I'm happy that I didn't get any regression for this. Yes, this is a classification problem. So well done, everyone. Thank you so much for participating. Now let us start again with some more theory things. So this is a machine learning life cycle. It consists of majorly 5 major steps that I have defined them into. These all steps are of equal importance, and this is actually a cyclic process, you can say, of consisting of these five, and these are actually in this order, particular order only. This is present. So I will be describing each step one by one, and it is going to be a bit descriptive. So we will try to learn this along with an example. We will take a use case of Netflix. So we all know Netflix, what it is now, but I don't know if you know this, that when Netflix started, it was just a mail service which posted DVDs in the US. But now you can see that it is a global streaming service with around 182.8 million subscribers. So how did Netflix reach up to this position? It was due to application of machine learning. In 2000, Netflix recognized the importance of giving personalized moving recommendations, and it started implementing. And in 2006, Netflix launched a prize, that was a competition that was being held on a machine learning and data mining, and in which a $1 million prize money was given. So that in that competition there was a winner, and that particular recommendation system, that particular model is being now used in Netflix till date. So let us now try to get into the different steps. The first step is define project objectives. So firstly, you need to find what is your objective that you are trying to gain, what is your aim that you need to achieve. So firstly, find those objectives, and for achieving that objective, what data do you think that you is useful for you, and try to get the different data sources. You can get it from several data sources that can be given, that can be provided to you. So identify all the data sources in this particular step. This actually lays the base or the foundation of all the above steps. So you know that Netflix offers a personalized recommendations to help you find shows and movies that can be of interest to you. Excuse me. So Netflix estimates actually the likelihood that you will watch this particular title that is present in the catalog on the basis of various kinds of features that we will discuss in further steps. So that was the objective of Netflix recommendation system. Now let us come to the next step, that is acquiring and exploring data. Now you have understood what is your objective and what do you want to achieve, and you now know about your data. Now it's required that you collect the data and understand what data is to be used and what data is not to be used. There would be several different kinds of columns, several different kinds of data that you would be getting. So try to just understand the data in this particular step. That is very important, because if you don't have the understanding, you will not be able to achieve nice interpretation of the data and the modeling in the next further steps. So what do you think? What Netflix uses as your data? Firstly, it uses your interactions with Netflix. Other than that, it also uses other members who have similar taste to you and preferences, their data. After that, it also uses information about titles such as the genre of the movie or show you are watching, the categories that you are watching, the actors that you love to watch, or the release year. So these are the data that Netflix uses and then gives you the recommendation engine. The third step comes, that is the data preparation. Excuse me. So now we have collected all the data. Now you need to prepare it so that it is in a good standardized format so that it can be put into your algorithm. So the first very important thing that you need to do is data cleaning. So in data cleaning, actually your data will not be perfect in the real world scenario. You will get some anomalies, you will get some missing values. So that is why it is required that you do the data cleaning step. You handle those outliers. There are different techniques for handling these kind of things, so you need to first handle them. Other than that, there is feature engineering, in which we try to create new kinds of features that can affect your data. So this is what is done in the third step, that is data preparation. So in Netflix, to personalize the recommendation, Netflix looks at some of the features like the time of the day that you watch, whether you watch it in the night, whether you watch it in the evening, what is the time that you prefer to watch. Then the devices you are watching on, that is your laptop, you're watching on your phone, what devices do you use. Other than that, it also uses things like how long you watch. One time, if you sit, do you do the binge watch, or you just watch one episode at a time, or one movie at a time? How do you watch and how long do you watch? So the when I was going through these, I came across a very interesting fact that this Netflix doesn't uses features like age or gender in your decision making process. So that was a very interesting feature that I came across when I was looking to the Netflix recommendation engine. So that was all about the third step. Next comes the model and evaluate. So till now, I and you would have heard a lot many times people speaking in machine learning model, model, model. So what is actually a model? Model is nothing but just a trained algorithm, a trained algorithm which is used to identify patterns in your data, and it does not require any explicit or manually set rules. I will help you understand this explicit and manually set rules with an example. You would have definitely used and you would be knowing about binary search. So in that, what we do is compare the search element with the middle element in the array, and then we look and then we move to the right or left of the array depending on that comparison. So that was some explicit manually set rules that you followed in the binary search. But what if this is not defined? The algorithm is itself being made and it itself find the best way to search that element. So that is termed as a model. You can take this as a very simple algorithm example. Here we have a linear equation, you can say, which is made up of a's and x's. So the a0, a1, a2, these are different numbers which are termed as weights, and the x0, x1, x2, these are the features, that is your input. So simple, this equation has been made, and if you put different values, you can get fx, that is your output. So this is just a very explanation about what is actually a model. And then comes that you need to actually determine whether your model was performing good or not, whether you were able to achieve your aim, whether it is good enough to be deployed or not. So for that, what we use is evaluation metrics. So here, evaluation metrics is not just accuracy that we come across, that the error, how much error is there. There are several different kinds of evaluation metrics present. One example I'll give you is of root mean square error. Root mean square is a very frequently used measure, and I'll be discussing it in the next slide also. So RMSE is nothing, just the differences between the values predicted by a model or an estimator and the values that are being observed. So on the right, you can see there is this formula of RMSE where y cap is the predicted value and yi, that is the actual value. So using this formula, you will be able to calculate your RMSE value. This is just one example of the various different kinds of evaluation matrices present, which are able to judge whether your model was good enough or not. So how does do you think Netflix makes a model? What is the model that Netflix has made? Firstly, it has to choose rows. If you have watched a screen of Netflix, you would have seen there are different types of rows present. Like here, I have shown you in this slide, there are different rows like violent TV programs, or continue watching for Dave, or top picks for Dave. If I tell you about my Netflix, it is something like more horror movies because I watch more of horror movies. So that are the choice of rows that Netflix chooses, that which rows is suitable for you, and it is different for everyone. The second thing is what title should come in that particular row. For example, there is here the example of violent TV program. So it has to judge whether the Breaking Bad comes in a violent TV program or not. So that is needed to be judged. After that, it ranks these titles. So you can see the top row is actually the most likely one to watch, and on the left is the most likeliest that you are going to watch, and on the right the likeliness decreases. So that is why here in our friend Dave's Netflix, you can see that the 100 is the most likely that he's going to watch, that is on the top and also on the leftmost. So this is the model that Netflix made, and this is the recommendation that you see on Netflix. So how do you think Netflix evaluates Netflix its recommendation system? So for that, it uses RMSE. Netflix uses actually made a model that had an RMSE value of 0.9525. So for your information, RMSE value of 0 is the best value that can be achieved. So in that particular competition that I talked about in the very beginning of this life cycle discussion, that there was a competition being held. So after that competition, there were people who got an RMSE. The winner actually got an RMSE of 0.88. When talking about these kind of things, I very much like to put your attention to this particular point, that in the future also, Netflix on that particular problem, if you see that particular problem is available till now, you can work on it. So there were some people who worked and in 2009 achieved a RMSE value of 0.8567, but Netflix did not put this into their recommendation system, because as we move forward to more accuracy and more accuracy, it needs more of cost and effort. So that is why nowadays industries, in actual industry, we don't lay that much time, we don't have that much resources, we don't have that much time, so that we can just work and go on working to make a zero error model. So that is why we define a particular aim, that okay, I want to achieve a 90% accuracy, and people are satisfied in the industry that yes, this model is achieving a 90% accuracy. So we always determine a evaluation metric value, that is the aim that we need to achieve. So that was about modeling and evaluation. So when you have now created a model that is satisfying your needs of the evaluation matrices, then you build a some things like API prediction system. It's actually depending on the use case. So whether you want the predictions to be given in the basis of an API, you do that, or maybe some other processes you can follow. Other than that, you also, the very thing that we always don't do is document, because you would like to make it, maybe you would like to make it in future, or maybe someone else would like to make it in the future. So document it properly, and then create a proper plan, that if you want that model to be improving on day basis, then you need to create a plan for monitoring and maintaining of that model. So Netflix also does that. It created the model long back in 2007 when the Netflix prize winner was given, but it continuously retrains its algorithm. It is obvious also, because something that I was watching 6 months back, probably I might not be interested if I watch it now. So that is why Netflix takes your feedback. Takes your feedback in how, that if it gives you recommendation, did you go and watch it or not. So using that, it trains and retrains its algorithm on a regular basis, and that is why it is now able to recommend you properly. So you can see, and when it was analyzed about the recommendation system, it was seen that 80% of stream time was achieved through this recommender system only. It's not always that you get a recommendation from your friend that okay, this series is going good, go and watch this. It was not always the case. So that is why people always open and see, okay, what can I watch, what can I watch. And almost 80% of the stream time was achieved just because of that recommender system, which is very impressive number. And Netflix also believes in creating an user experiences by creating a retention rate. So if I talk about the industry, there are companies who spend a lot of money to bring the consumers to their products. You can see different kinds of advertisement, the digital marketing that is done. So it requires quite a lot of money and effort to bring a particular consumer to your product. And after that, if the person leaves, then you would again need that effort and that money to bring that person again. So that is why Netflix always focused on keeping its customers to itself, and this, because of this, it was almost able to save around 1 billion as of 2016. So you can see how machine learning was so useful for Netflix, and this is the use that every industry everywhere is being applied nowadays. So now, a lot about machine learning and types and things like that. Now I will come to the major point, that how to start if you're looking to go into machine learning. So I would just share a very simple path, roadway you can say, just for starting your journey in machine learning, because after that path maybe your journey can be totally different, but this is just the starter journey. So, firstly, the major point before starting it is that you should understand whether machine learning is something that you really want to do. I know machine learning is the buzzword nowadays, everybody wants, and I can see that nowadays everyone in the college, they are very much leaning towards machine learning, machine learning, machine learning. But are you actually interested? Try to grasp, okay, it excites you, but really, do you want to go into that calculus, that algebra of machine learning algorithms? Are you that capable and understand your capabilities? It's not that only machine learning is booming, you can go into a very different field also, and you can build your career there also. So actually first determine whether you want to go into the field of machine learning or not. After that, when you are decided that okay, you want to go into machine learning, firstly learn something. Some prerequisites are there that you should learn. So firstly, learn a coding language. You can go for Python or R. I generally suggest people to go for Python. After that, you would definitely, and you are going to need, that is statistics. Statistics is a thing that we engineers always lag in that. So that is why I really had to put a lot of effort to study statistics. So that is why I always suggest people that first learn statistics, and after that you also had to know mathematics. Mathematics in that scenario, what you are going to need in this particular field will be mainly algebra and calculus. So get courses for all these different kinds of things, and you can then start working on machine learning. That is my next third step, that when you are now done with your prerequisites, then you go to learn the machine learning. Try to learn different kinds of algorithms. I talked about supervised, unsupervised, so there are many different kinds of algorithm present inside them. I talked about reinforcement learning, I talked about unsupervised learning. So what are that, the description of all the algorithms present in them. Try to learn in this particular step. And when not go for not don't go for learning all the algorithms, definitely some basic algorithms you can take, simple courses that can teach you major of the important algorithms. And now when you are done with that, now start making projects, because that is what is going to light in your resume, and that is what any person who is going to recruit you or hire you is going to look. So try to make projects and not just simple any projects. Try to create projects that are some value to the society, because that is one of the catchy points, that people feel that if you do something that is particularly useful in the society, then that is considered as a very good project. And also try to use, not just like if you use just a simple linear regression and made a particular machine learning algorithm, that is not is suggested. Try to use the most complex thing that you are able to do. Try to go into that kind of things. Try to make a little bit complex, so that if you tell and describe it to anyone, it would feel that okay, the person has done something. Other than making projects, you can take part in competitions. There are different kinds of competitions being held. You can go into Kaggle, you can go for Analytics Vidya. These are some very predominantly useful sites where you will find very particularly very good competitions which you can participate. So it's not that always you go for winning. You can learn actually a lot in those competitions, because there are many people who apply different kinds of techniques, so you can learn from them, and it is a very good learning experience. I found it pretty useful for myself also. And when you are now done with that, now along with this you start applying for internships and jobs. And for internships and jobs, you can go for all the different kinds of platforms available. You obviously know them, so you can go for them and start applying for the internships and jobs. So that was all for someone who wants to go a lot into depth of machine learning. But what if you are not good at coding? If you're some from another branch and you don't have that language knowledge about this, so then what should you do? You can go for machine learning services. These are some of the very widely used machine learning services by Amazon, Microsoft, and Google. So you can use these kind of services. These are simple drag and drop. If you just understand what is machine learning, what steps should be used, the life cycle of the machine learning, then these tools that can be particularly useful. I used Azure once, and it was so easy. You just need to drag and drop and drag and drop, put the data and match the columns like this, dots. You need to match what you want to do after this, put that box inside that, and after that you get a well trained model. So these are some of the very useful machine learning services that you can go for if you do not want to go into the coding section. uh, okay, well, most of all is done. But if you don't want to even spend that much, if you don't know anything about machine learning, and if you don't want to deep dive into machine learning, and still you have to implement machine learning in some other field, some other branch, if you are not in some computer science, ITEC, you are not in such branches, and you didn't have much idea of machine learning, how can you go for them? Then you can use what things that is known as AutoML tools. These are very useful tools. These are automatic machine learning tools, you can say. These are some of the top tools: H2O.ai, Splunk, Google AutoML, and Data Robot. So what actually happens in these kind of tools is that you simply put your data into the model, data into these interfaces. Actually, these are web applications. You simply need to upload your data. It will automatically determine whether it is a regression problem, supervised, unsupervised, it is a regression or classification. It automatically finds that. It finds all your features, whether they are important, if there is a missing value, there is an outlier. It handles everything and gives you output. Now you can easily implement them using APIs. You can simply call them from whatever application you are using, and you can get the predictions. So these are the AutoML tools which are more easier to use. But yes, these are some things which are very costly that we won't be able to use on our own. When you go into the industry, you will be able to get these. I particularly in my company use Data Robot on a regular basis, and I can tell you that it is really very very fast and time saving for me. So I think this was particularly useful for you. These are different social media platforms on which you can connect with me. And if you have any doubt, you can ask me now. I can try to answer you till then.
Thank you so much, ma'am. Uh, we have a few questions for you.
Yes.
You can see they're there on the chat of the meet. Would you like me to read them?
Uh, yes.
Okay, so the very first question is, how can machine learning help us interface with equipments connected through IoT?
Okay, so in IoT, if you're using, you would be particularly using Python for it. So you can implement your machine learning algorithms into that coding section that you're doing. So in IoT also, if you're working on sensors, then I have particularly worked on some use cases where we use the sensor data to detect whether the machine is going to fail or not. So that is one of the major applications where you can apply machine learning into IoT. Yes, I think I answered the query. We can go for the next question.
Ma'am, the next question is from
Yes.
Sumit Kumar. What if someone don't have particularly behavior regarding the shows? So which one to take priority? Who decides this, or it's just business action, not as part of problem solving? This might be from one of the quizzes.
Can you just repeat? It was a long question. I'm sorry.
You can check in the meet in the
Yes.
chat section.
What if someone don't have particularly behavior regarding the shows? Sh- So which one to take priority? Who decides this, or is just business action, not as part of problem solving? I am really sorry, but I'm not able to understand the question. What particular behavior regarding the shows means which show?
Ma'am, it's okay. We can skip to the next question. I
Yeah.
think he didn't make himself that clear.
Can we get a RMSE value of 0 in future? It's actually the ideal scenario of getting a RMSE value of 0. So I don't think that Maybe in future when we have lots of computations, we can achieve a RMSE value. If you can train your model for 30, 40 years, probably you can get a RMSE value of 0, but currently it's not possible, and people don't go for RMSE value of 0. Okay, the next question is from Himanshu Jaswal. How to decide when to use KNN model or tree model depending upon problems? Actually, that depends upon the use case, what you are going to use, and the data also. Because I have seen that similar kind of data, it can change. Its means the algorithm which fits into that particular problem can be different for different data. So that is why it's best that what I do is simply like a brute force, that I apply both of them. So you can try to apply both KNN model and tree model. And obviously one more thing that you can use for deciding this is there are some restrictions actually on some of the algorithms. I'm not just talking about KNN or tree model, but there are some restrictions on many of the models. So you need to, that is why you need to understand each model, each algorithm that you are going to use, whether the data is satisfying or is satisfying those particular conditions or not. Are there any more questions?
No, ma'am, that was it.
Okay.
Thank you so much, ma'am, for guiding our viewers and sharing your experience with us. I hope our viewers had a nice time. And I really hope that whatever you said, this sparks interest in our viewers in the field of machine learning. And thank you so much for clearing all their queries. Uh, and definitely all the quizzes you had, it added to the talk. Yes, I can hear you.
Okay.
Have more been posted?
Are Automl tools at par with manually trained models? Yes, they are at par, because actually in Automl tools there are different kinds. Means I think they provide you around 20 to 30 different kinds of algorithm. It trains on each of the algorithm and then tries to determine which one is performing the best. So that is why I have found that these are much at par with the auto, means if you're manually training any algorithm. Next is why graph and graphical representation is necessary for machine learning. I think you probably need to understand statistics first, because in statistical analysis we generally use graphical, because you need to understand the data, whether a particular distribution is being followed by the data or not. If some outliers are present, why is it present? So if you are trying to understand the data, you need graphs that are more to catchy to your eye and more easy to understand and interpret. That is why you use graphs and graphical representation. Okay, could you tell us more about generative adversarial networks? These are actually generally generative adversarial networks. I generally don't use the full form. It's known as GANs. We use that. So it's actually a technique of deep learning in which when it is generally used when you don't have much of input data. So in that scenario, what this does is it automatically replicates and try to create more of the data similar to the input data. So this helps in solving your problem for when you have less data. So I think this is mainly used when in image processing. So if you're going for some problems like that, you can go and apply GANs in that. Okay, next is, do we need to use all the features for training the model? Actually, in the feature selection section, that was the third step where we were preparing the data. In that step, we try to determine which is important feature and which is not. Many of the people I have met, they try to put all the features first, and then they determine which is important, and they remove all the features that are not important. They are not playing much important role in the equation that is being made. So that is why we don't always use all the features. We determine which is important and which is not important based upon the model, and then we select. That is done using feature importance actually. Okay, next is with just average CP. How can one land at high pay jobs through machine learning being CSE guy? Okay, the majorly the most important thing here is your knowledge. If you have knowledge, you can definitely go directly to Google, Amazon, or any big companies that you aim for. So simply just try to get the knowledge. Try to make different kinds of projects which are very useful and uses your knowledge very nicely and extensively actually. After that, go for competitions. These competitions actually play an important role in making you recognizable also. And when you are applying, you can use LinkedIn as a very powerful tool, I can suggest, where you can get different referrals for the bigger companies. So they don't only prefer that you should be coming from IITs or NITs only. They, you can go obviously and you can lie on a very high paying job. Next is moreover is that we can use same data set as training and testing. No, we don't use the same data set for training and testing because that leads to overfitting of the model. So that is why we don't use same data for training and testing. Could you tell us about reinforcement learning? Yes, as I talked about in the session in the presentation, that in reinforcement learning we train the model using feedback. So you can take an example of a robot. How is robot trained? That is using reinforcement learning. So when it like it hits a wall, that is given that it has hit a wall, and this is a way that it didn't had to go. So that gives it a negative feedback. If it is able to move 1 centimeter, it is given a positive feedback that yes, this is a place where I can move. So that in that scenario, using the positive and negative feedback, this particular robot is able to understand that for these particular values whether I should move ahead or not. So that was, I think, a little bit more explanation about reinforcement learning. Maybe Sumit Kumar wanted to ask how Netflix recommendation system works in those cases where user behavior is not fixed so that a person cannot be classified in any particular label. Yes, actually, when you start Netflix, it doesn't give you a personalized recommendation system just at that moment. It tracks your behavior, and after that it improves and gives you better recommendations. But if you have started Netflix, in the first, you can see it asks you some of your likes, which actors you love to watch, or some things. It asks few questions, and there is a very generic model that is being made, a very generic, you can say, a generic that people generally watch. These are some shows that yes, okay, people are obviously going to watch Friends. So that is some very general things that is given on the first page whenever you visit a Netflix website. So when the behavior is not decided, it the Netflix uses that, you can say, a dummy behavior for all the users. So I think I was able to answer the query of Sumit with this. Best way to avoid overfitting and underfitting problems. Actually, overfitting and underfitting, I hope you understand both the terms. So for avoiding overfitting, you need to means actually depends on the hyperparameters also. There are different algorithms. So if you keep on repeating and training the model and train it very much also, that leads to overfitting. And if you train it less, it turns to on underfitting. So that is why we try to find an optimum value of all the hyperparameters that are present in any algorithm, and with using that we create a optimal level, and we are able to avoid both overfitting and underfitting. So you can go for hyperparameter tuning, and you can use, there are many techniques like randomized CV you can use. So you will be able to use, or you will be able to decrease overfitting and underfitting. Obviously there are some other features, like you can go for adding more data and things like that for avoiding overfitting and underfitting. But the most important thing that you need to do is hyperparameter tuning. Okay. Also in evaluation metrics, Which parameter is good to rate our model? Actually, there are different kinds of evaluation metrics present. Sometimes, if I give you an example and describe you very briefly, it is like if you go for a cancer detection. So if you're seeing the images, person is classified whether a person has cancer or not. So in this scenario, what your focus will be there, that you don't want to miss anyone who has cancer, and you classify it as non cancer. So here, that is the most important thing that you need to avoid. While in any other scenario, there would be something that you need to avoid, something else. So it depends on various use cases. There are different evaluation matrices like precision and recall. You can go for RMSE, log loss, Gini's value. There are many things. So depending actually on your use case, what you actually need to focus on, that you for that actually the evaluation matrix changes. Is AI a job killer or job creator? Okay, so this is actually a debate question that I've got. But yeah, I being in this field, I can say that it is actually AI creator. I don't find it as AI killer, because job it I don't find AI as job killer, because like when you can imagine just a simple scenario. When computers came in the first, it was said that it will take jobs of the people who do the work manually, but actually it improved your performance, and you people started using machines and using computers, and obviously led to an increase in efficiency, and it didn't kill any job. So that is why this is also something just like that. It is actually the maybe the field, the work can change. You need to adapt yourself to the newer technologies. You cannot keep on doing the same work. It will definitely kill the previous jobs that were there, but it will also create new jobs. So that is why I don't consider it as a job killer. Is it a myth or AI? Sorry, is it a myth or truth that someday machines could develop so much that it can overpower humans? Yes, it has actually. There is a graph which I can remember, which was being made upon the performance of performance of human beings and performance of the machines nowadays, and actually the machines have surpassed us. We almost do anything work with a accuracy of 95%, and the models can be these machines can do that particular thing with an accuracy of 97%. So it has actually went above our capabilities. Does research in AI need to be regulated like is done with genetic research? What do you mean by regulated? Means you are you meaning Salish that something like or human cloning? Okay, I think what you're referring to, that it should not overpower human beings in the future. So definitely, I think that a bit of, yeah, as you are saying, a bit of government intervention can be there to restrict, because I just recently I watched that series on Netflix that was Social Dilemma, I think. So I think if you watch that, you can see that importance, that yes, government should actually get into it. Is overpowering humans not dangerous for us? Yes, it is. That I think Shailesh was also trying to ask that. And yes, we need to regulate it definitely. But yes, with the optimum level of regulation, I think they will be, if you train them and if you make them just to work for you, that is well and good. You should not make them that it should be above you. Maybe it might be doing things that you can't do, but it should be just under you, following your instructions. I think that ends all the questions that would present.
Yes, ma'am. All
Yeah.
the questions are over. Thank you, ma'am, for answering to the questions of our viewers.
Yes.
There is a short notice for our viewers on live stream. The link of a short feedback form has been shared through live chat box on YouTube. We request you all to give us your feedback about the session. And over to you, Kiran.
Am I audible now?
Yeah.
Okay. So with this, we come to the end of our 4 days, 5 talks webinar. I thank all our viewers for staying tuned with us throughout. And I really hope that whatever we brought to you, you found all of that very useful. Our speakers have put in a lot of effort, and I really hope all of that was beneficial for all of you. So, giving a quick review of what we had. We started on the first day with microservices and architecture. Then we had a lecture on VLSI, and uh, we the next day we had a lecture on optical fibers and its applications. And following that, we had career guidance from a Googler. And today we had Mansi ma'am delivering this lecture on machine learning. So that was all from us for this particular webinar, but we'll be coming up with more and more events in the future. So over to you, Nidhi.
Thank you, ma'am, for answering to the queries of our viewers. We thank you for guiding our audience. Now we will end the session, and I would like to inform our viewers that we will try to bring even more new exciting events for you all in future. Stay tuned with us through our YouTube channel, IET Students Chapter BIT Sindri, and through our Facebook page, IETE Bits. Stay safe, stay healthy. This is IET Students Chapter signing off.